and I'm going to be talking, or start today's seminar talking about how we visualize the invisible around indoor environmental quality and how that concerns people in the room. We'll be talking around indoor environmental quality within buildings, and a lot of what we'll talk about will be particularly in offices, but some of the context can apply across all types of applications of buildings, schools, hospitals, and any building obviously where people are affected by the indoor environment. So why is IEQ important? We have some factors which are more soft factors. It can be to do with health, how we look after the building, our well-being, and there can also be special applications such as hospitals, museums, laboratories, manufacturing facilities, where the indoor environment can be particularly important. There are also other factors, some more hard factors, such as performance of the building and the ventilation system in particular, the energy use that the building consumes, the economy and how the building is used and how that affects particularly productivity, and of course how all of these go together that affect the climate and the whole world that we live in. When we talk about indoor environmental quality, we don't just talk about air quality, but obviously that is an important factor. We can also talk about humidity, thermal comfort, light, and something that's not very often considered, the actual acoustics within the room. And all of these have impacts on our health, our well-being, our comfort, and also our productivity, which we'll talk about in more detail as we go through the presentation. So when we talk about us as people and humans, we consume around 1.5 kilograms of food per day and about 0.75 kilograms, sorry, I got the wrong way around. We consume around 1.5 kilograms of liquid a day and 0.75 kilograms of food per day. But a lot of people don't realize we actually take into our bodies around 15 kilograms of air. So in terms comparison, it's just a huge amount. And then we also spend nearly 87% of our time indoors on average, which means we spend 13% of our time outdoors. So the indoor environment is really important when you consider the amount of air that we breathe. When we talk about indoor climate and we talk about ventilation in particular, the reason we ventilate is to remove impurities from the building and to remove excess heat. And then we replenish that with nice, clean outdoor air, and we want to maintain the right temperature in the building. The indoor climate can have links to our health, and Åsa is going to kindly tell us about some of those.
Yes, thank you, Dean. So from some studies that we put together, we also know what happens if the ventilation fails or if the ventilation is insufficient. So we get different symptoms, especially in the workplace where studies have been made. We see that people get headaches. You also get some problems with your irritation of eyes, your nose and your throat, and you can get some repeated respiratory infections. And after the pandemics here, we also know that there is an increased risk of airborne viral transmission if the ventilation is not sufficient enough. You can also encounter tiredness, concentration difficulties, and also nausea or dizziness if you don't get good indoor climate. So what causes this? What lies behind poor health? Well, in this picture, you can see different things that affects us indoors. For example, cooking and heating of the building in the building emits ultrafine particles. That is particles that is less than 0.1 microns and in diameter, and those we breathe into our lungs, and they are transferred over in our blood system and affects us in different ways. Of course, we get some irritation in our lungs, firstly, and then we also get an increased risk of cardiovascular diseases. We also have chemical products in the premises, products that release chemicals, such as furniture or newly painted walls, etc. So a lot of those affect us also and can lead to asthma or respiratory problems. One thing that also affects us is the moisture or humidity. If we get an increased moisture level in the buildings, we can also get a risk of other substances that is increasing in the air, such as mold mites, volatile organic compounds. We also have substances from bacterial growth, etc. And also a release of chemicals that also gives us increased risk of allergies and asthma. And one factor that Dene mentioned is also noise that affects us in a very big way. If we are continuously exposed to monotonous sound in the form of persistent tones in our occupied environments, it could give us long-term effects on our health. One study from the World Health Organization in 2011 called The Burden of Disease from Environmental Noise says that we lose a number of years only related to environmental noise.
Thanks, Åsa. So some of the things Åsa said obviously can be very detrimental to our health, and that's just from our indoor environment. But we also can consider how does the indoor climate affect our performance. And as I said earlier, that performance can be work related, but it could also be recreational related. So this slide shows a couple of charts. The first chart on the upper right shows how our relative performance can be affected by the temperature in the room that we're working or playing in. And the optimal temperature is somewhere between 20 to 22 degrees. And you can see from the curve how the relative performance can decrease when we go to either side of that temperature range. The diagram on the bottom right shows how the perceived satisfaction of the indoor climate can reduce performance as you move away from the most optimal temperature. So the dotted line on the chart shows if we move 1 degree to the right of the optimal temperature, the reduction in performance can be as much as 25%. And if you follow the curve even further to the left or the right, you can see that if we go to 2 degrees away from the optimal temperature, that can actually reduce performance by 80%. Two further curves show how the indoor environment can also affect performance when we talk about both airflow and air quality. So the chart on the left shows how just by increasing the airflow, there is a perceived level of performance enhancement. The upper curve on the chart on the left shows if we start introducing air at 6.5 litres per second per person and then increase it, the levels of performance increase higher than if we start introducing air at 10 litres per second per person and then start to increase it. And you'll see that somewhere around 20 litres per second, the increase after that doesn't really increase at such a great rate. So if you take that curve into consideration, just by increasing airflow from 6.5 upwards to around 20 litres a second gives you the best increase in performance of people. And then the chart on the right hand side shows the correlation between perceived air quality and poor performance. So if people perceive that the air quality is poor, they actually perform worse. So it's really important that people feel comfortable within the space that they're working in to make sure that they perform to their best potential. The next slide looks at a study that was conducted by looking at air quality and using CO2 as a measure of what the air quality was. It was conducted using different methods, and this particular example shows how, with levels of CO2 at around 500 parts per million, people's strategic thinking as a cognitive function was measured. And you can see from the chart that it was relatively high, but started to decrease as the levels of CO2 were increased. And when the levels got to around 1500 ppm, the strategic thinking cognitive function had reduced considerably. Some other studies recognized that it was the same for being able to look at something and remember it as well. So if you think about a learning application, or where strategic thinking takes place in meeting rooms and boardrooms, it's really important to make sure that the CO2 levels are kept low to make sure that the cognitive function is as high as possible. And when we look at relative humidity, we can also look at how relative humidity and moisture in the air can affect our health. The optimal range for relative humidity should be kept somewhere between 30 and 60% RH. And that's because in those ranges, lots of bacteria, viruses, flu, bugs and things like that are less active. So it's really important that we have that, but it's also good for human health because a too dry air can cause dry eyes, dry skin, eczema, and it also can harm the building because the building can shrink and crack. And if the moisture is too high, then that can cause damp and mold and spores, which can also be hazardous to human health. The next slide, now we talk about noise and how noise can affect us just from a performance perspective. And you see the chart has a correlation. As the noise increases, the levels of concentration decrease. If you use an example of an office environment where normally in a normal day, the office is quite quiet, people are just doing work, but then one day, a number of employees that don't normally work in the office come in, there's an increased amount of talking and disruption, and you can understand how your concentration lapses just because of noise in the background. So just a quick summary, how can we make people more productive? We talked about temperature, try and get the temperature in a range between 20 to 24 degrees C, increase airflow to somewhere around 15 litres per second, and also control the temperature and humidity and the air quality. When we talked about dissatisfaction, if people can control the air quality and the temperature, then obviously they feel more satisfied. So it's quite a good strategy to be able to have more zones that people could control, or smaller rooms that smaller numbers of people can be in the room and control all of those aspects.
I had a question actually, Dean.
Yes,
we spoke about increasing outdoor airflows, which is perhaps at odds with the sort of general societal trend of being more sustainable and conscientious about energy use. A question for the panel: what things could we do to mitigate some of that energy usage?
Anyone else want to answer?
Well, one of the things that we can't do is that we can demand control the ventilation based on the usage of the building, which means that we ensure that we have a good indoor climate when people are there, while we are able to save energy when they are not.
Okay, that's a good answer.
Did you want to add anything?
I suppose the other thing, if we're looking at energy and increasing airflow, that can have a knock-on effect to the energy we use to heat and cool the air to maintain the temperature. So having a good high efficient heat recovery system or energy recovery system within a ventilation system will help keep those mechanical heating and cooling costs to a minimum.
Yeah, and I think also that you monitor and see how your system is working, so you also maintain it in a good level.
Yeah. Which is interesting and fantastic to link us to the next piece, which is Caroline, you telling us a bit about what we would measure with the indoor climate.
Yeah, sure. And to start with, you can ask you, why should you even measure the indoor climate from the beginning? And as both Dene and Åsa has spoken about, we know that the indoor climate has a lot of effect on our performance and health. And it is invisible, the indoor climate. So if we don't measure it, we don't really know what we have. And if we don't know what we have, we're not able to do anything about it either. So there are a number of common measurements that you can use to measure and assess the indoor climate. We have, for example, temperature. We have relative humidity. We have air quality with VOCs, CO2 particles, for example. It is also possible to measure noise and light. And I'll talk a little more in depth about a few of them, which are most common and relevant to measure. But not only measure, you can also use them to visualize the indoor climate to get control of the invisible. And I will start with temperature. Temperature is likely the most commonly used measurement of the indoor climate. It is relatively easy to measure, and as Dene said, most people are satisfied with a temperature somewhere between 20 to 24 degrees. However, it is nearly impossible to satisfy everyone with just one temperature. And the perceived thermal comfort varies a lot with, for example, drought, radiation, activity levels, clothing, and the humidity in the room. Another term that we often hear of is air quality. That is a bit harder to define as it is more complex than the temperature. We frequently call poor air as a lack of oxygen, which I think you can all relate to. But that is not really true, because the fact is that the bad air quality is often a result of wrong temperature or level of carbon dioxide and other gases that affect us. And carbon dioxide is something that is quite often measured and used as a common reference for the indoor climate, since it is a good indicator of human presence in a building. Carbon dioxide is a natural product of our breathing. It is measured in ppm, and the normal outdoor level of CO2s is around 400 ppm. As Dene said, research shows that our cognitive capacity is affected around 1000 ppm, but it requires much, much higher levels before it becomes unhealthy or even dangerous for us. But due to the fact that our cognitive capacity is reduced around 1000 ppm, that is often a level that is used as an upper limit, for example, for ventilation control. And since CO2 is quite easy to measure, as I said, it is quite often used as a common reference for indoor air quality. However, only measuring CO2 can be a little bit too narrow, since it does not cover other pollutants that are quite common in buildings as well. There we have VOC on the other hand, which is a good indicator for other pollutants. VOC stands for volatile organic compounds, and it is a collective measurements of thousands of different substances. It is often measured and visualized in a total VOC number. And some of these compounds are emitted by humans, whereas other are emitted by, for example, building material or different products used in a building. It can be, for example, formaldehyde coming from paint. It can be alcohols from adhesives and solvents. And it can be benzene, styrene from copiers and computers, which are very commonly used in all types of buildings. So it is quite interesting to wonder, when should we measure CO2 and when should we measure VOC? Both of them are quite a good indicator of presence and pollutants. As you can see in the diagram to the left here, this shows that VOC quite often follows CO2 quite good when you measure it. And VOC and CO2 can therefore be good both indicators for controlling the ventilation, for example. But in the diagram to the right, you can see an example of how VOC sensor captures other pollutants that the CO2 sensor does not. For example, perfume sprayed in a bathroom. So CO2 is often a good indicator of human presence, whereas VOC will also react to other pollutants. And VOC can therefore be considered more comprehensive when it comes to measuring the air quality in total in a room.
Fantastic. Very, very interesting stuff. In the UK, they've made, in certain types of buildings, CO2 monitoring mandatory. Is that something you think will continue across Europe or you know, beyond? And if so, is CO2 the right thing, or should it be VOC?
Yeah, it's quite an interesting question, actually. Well, with the recent pandemic, we have learned that viruses is often an issue, and as I mentioned, CO2 is a good indicator of human presence, which can also, for example, be an indicator of viruses, etc., which makes it relevant to measure due to the fact that we want to ventilate it out. But it also does not cover other things, such as other pollutants, which will affect our health and performance. So I don't think that it's either CO2 or VOC or particles or something else, but perhaps a combination of them.
Did you want to add anything?
No, I think the UK initiative to add CO2 sensors in schools to measure if the airflow is sufficient, I think that is a very good start. So then you can decide what measurements to add to that and to create a good indoor climate.
Absolutely. Absolutely. So now also, I think you're going to talk to us a little bit about the economy of running a building and how IEQ actually affects building economics.
Yeah, I'll try to.
Fascinating.
Yeah. So let's look at how the indoor climate affects the economy of the building, and is there any good reasons to invest in the indoor climate? And of course we think so, but also research supports this. It shows actually a significant productivity increases with people that are staying in the buildings that have a good indoor climate. So 1% increase in performance capacity in premises corresponds to the whole ventilation cost of the building. So it's really a very good investment, and the repayment, the return of investment, is less than 2 years actually from studies that we have taken part of. And the table that you see in the slide here is a compilation of existing research and shows how average productivity increases dependent on the different IQ factors, such as thermal comfort, ventilation, air quality, and also light and sound. That is an important part of this. So as you can see, IQ is a good investment. But what might this mean economically? I have hard stuff with the English words here. But we have a study and an example from the Harvard University. It was made in 2018. And it puts value on the energy cost associated with increased airflows, as we looked at in your charts previously. And it puts this in relation to what human efficiency gains you get from it. So if you invest a bit more in the ventilation system, that you invest in a bigger air handling unit in this case, then you can also get increased productivity that well exceeds the investment cost. And you get that in return over and over again. So the range to the left in the picture is between 18 and 40 US dollars, depending on what kind of energy efficiency you have on the installation, on the products installed in the building. So this is a good investment. Yet another example where STOK.com, a team of interdisciplinary experts in the real estate business, has compiled the results from current research and presented in a study called The Financial Case for High Performance Buildings. And what is high performance buildings? It's the building where in the design phase, they taken into account, amongst other things, the indoor air quality and ventilation, thermal comfort, natural and artificial lighting, noise and acoustic, active design, and views on biophilia has been used in this. And you can see in the diagram the areas with the greatest financial impact of a high performance building is actually the increased productivity with people and also the reduced staff turnover. So this means that you will get a good saving or return of investment because people want to stay in the building for a long time, and they also want to stay with their employer. So that's not so bad.
That's
good, for sure.
And the last example that we have when talking about the financial part is that if you break down the total annual cost for the business in an office building, is that the business related costs are a smaller part of the cost. It's about 10% actually. And of these costs, to get the building in place is only about 40% of the total of that. And then in part of that, the cost for installation and ventilation and air conditioning is just a few percent. And despite the relatively marginal cost of the ventilation system, it has a major impact on the total office building cost. And for example, if you can make a small extra investment and invest in a smart and demand controlled ventilation system, you can not only boost the level of indoor climate and productivity, you can also reduce energy costs, of course. You ventilate, heat and cool when there is a demand, and not all the time. And according to that, you can also save a lot. And you can also get a good and healthy building for people and environment. And as a matter of fact, if you move from CAV systems, where you have a constant air volume, to demand control ventilation, you can earn a lot when it comes to energy, up to 80% saving on the fan energy, and also up to 40% saving on heating and cooling energy. So that's a good deal.
That's pretty fantastic. That's really, really interesting. Really, really, really good stuff. So I now wanted to just comment on societal demands, if you like, and how societal demands affect what we do with the building and the indoor climate. And when we build, I mean, there are some mandatory things we have to do. We have to make sure that the building's safe, fundamentally, of course. We have to comply with laws and standard building regulations, and some building types also have their specific requirements, you know, healthcare facilities or schools, for example. But then there are some optional certifications, some around health and well-being, some of them around sustainability, energy efficiency, responsible construction, and so on. And I think it's fantastic because these buildings, from a value perspective, their value could be greater, more desirable, and the more people and clients and tenants want to occupy sustainable buildings and sustainable facilities, and facilities that make them feel good inside and they're aware of it. I mean, that is a trend that I think will only continue and continue to be highlighted. So that brings us towards a short summary, and then we'll take your questions. So if you, whilst I go through the summary, if you want to submit questions, if you use the Q&A box on Zoom, which is in the bottom right-hand corner, you can send us some questions through that. So just to summarize this visualizing the invisible section, what have we learned? Well, we heard how the indoor climate has a pronounced impact on people from a health, a comfort, and a performance perspective. We learned a bit about, the importance of visualizing and also measuring the indoor climate, because if we're not measuring, we probably don't understand it. And then the impact that it has on the building economics, which is, of course, both from a value of the building, but also the potential sort of savings through the people and so on. So that's really, really insightful.